So we're going to do these two problems. It says solve the system of equations. So that's what we're going to do here. The first one, we're going to solve by the elimination method. The second one, we're going to solve by substitution. So there we go. So for the first one here, if I look at the elimination method here, I want to make my x's or y's opposites. So I'm going to make my x's opposites. So I'm going to take this top one and multiply it by -3. So that's going to give me -9x plus 3y equals -21. And then the bottom one I'm just going to bring down. Just bringing that one down, I didn't do anything to it. So that's going to be 9x minus 3y equals 21. Then I'm going to take those two and add them together. Now, if you noticed, both the x's and the y's are opposite here. So that means for this left side, I'm going to get 0. And then for the right side, look at -21 plus 21. Those are opposites as well, so I'm going to get 0 over there as well. So I get 0 equals 0. And that means infinite number of solutions. But we don't just write it this way. Another way we can write this, or the way we should write this, is x comma y such that y equals, now essentially what I'm looking at here is I'm looking back at the top. That'll be here. And all I'm going to do for that equation is actually solve it for y. When I solve it for y, that means essentially I'm going to move the y over here and the x over there by using addition and subtraction. So I'm going to end up with y equals 3x minus 7. So that's what I'm going to write in here. So this is going to be y equals 3x minus 7. And then I'm going to say x is any real number. And then use my other squiggly bracket. So that's what I would say for a problem like this. I would say my final answer is that. So now what I'm going to do is I'm going to do this other problem to the right here, this number b. Now for substitution, I'm going to solve either my x or y in either one of the two equations for x or y, and then sub it into the other equation, the one I didn't use. So I'm going to use the top one here. If I move the y over by adding y to both sides, I'm going to get y equals 2x. Now essentially all I'm going to do with this is plug it into the other one, and this is the substitution method. So I have 4x plus 2. Oops, I ran into a y. So I put my 2x in there, and then I have an equal sign to the right of that, and I have a 12 here. Okay, so again, I'm using this bottom equation here. That's what I'm doing. So now what we're going to do is just simplify this. So this is 4x plus 4x equals 12. Okay, so then I get the 4x. That's going to give me 8x over here, which equals 12. And then when I divide by 8, I get x equals 12/8, or 4 goes into both of those. So that would be 3/2. So then what I do is I take that and I plug that in into either one of the two equations. But I'm going to pick this one right here to the right, this red one, because I got it set up real nice already. So that's y equals 3/2. The 2's cancel. I get y equals 3. So my ordered pair for this one would be 3/2, comma 3. So there's our answer for that one. So as you can see, I can get all infinite number of solutions, which gives me this kind of answer here. Or I can just get one solution here. And there's another one too. Let's say I ended up with at the bottom, like what happened to the left one here, this one here. Let's say I ended up with 0 equals 4. Now is that a true statement? No. So then I would write no solution. So that one we would call what they said in the problem is inconsistent. Okay, that type of solution would result in an inconsistent. So just kind of keep that in mind too. And one more thing here. When I do end up with this 0 equals 0, they also call that identity. So just something to keep in mind if you hear that language. What's identity mean? Identity means that it's infinite number solutions. 0 equals 0, or some number that's the same equals some number. So there you go.